In this tutorial, we learn to calculate the psi value in BISCO. We will continue to work on the same file we developed in the previous video, where we calculated UF value of the frame. If you haven't watched the video yet, we recommend watching it before you begin this video. We must now replace the insulation panel with double glazing, to calculate the linear thermal transmittance of the spacer at the glazing edge. We will override the color 28 with real glass. We already created a bitmap glass using similar dimensions of the panel through a DXF file. You can directly download the corresponding files from the link mentioned in the description below. Zoom into the left top corner pixel of the panel. This now would be the reference pixel where we will place the bitmap. On the bottom at the status bar you see the coordinates of this reference pixel. From the bitmap menu choose Import Bitmap and choose the file. Then the bitmap origin dialog box appears. The reference pixel coordinates are initialized using the last clicked pixel. Click on OK. The colors in the imported bitmap have been chosen by the Use Template Color database. Here we see all the colors have properties of desired materials except color 17. We will adjust this later. Secondly, we made the glass panel smaller, and it's not fully covering the insulation panel. We can add color to the remaining part manually by using a rectangle tool or a line tool. Instead, we can use the bitmap size function, which is the easiest. Under the bitmap menu, choose size. We say remove 500 pixels on the right by inputting -500 to the right margin. So we first remove, and we do that again by adding the same amount from the bitmap size function. Here we select and choose border colors to extend the pixels on the border. For color 17, we need a cavity, but in the color database it corresponds to limestone. From BISCO version 13, standard EN673 is available in the color window. Now, for color 17, we change the type to Equimatte and toggle the standard to layer EN673. Then, the physical flow direction of heat is horizontal and change the geometrical heat flow direction to Y. The software now treats the cavity as an equivalent conductivity, including the effect of convection and infrared radiation. Double-click on conductivity to input gas mix for the cavity as 10% air and 90% argon. The surface emissivities of the adjacent glass layers are 0.837 and 0.037. The 1D U value of the glass can be read from the right border U value. You can also create a predefined glass cavity layer in the color database, and an example given in the color database is 194. We have already discussed in the colors tutorial to edit and customize the color database. Now we need to know the psi value of the spacer. For this, we calculate the 2D heat flow for the complete geometry divided by the temperature difference, and then subtract with width of the frame multiplied by the UF value of the frame, which we calculated in the previous video. Then subtract with width of the glass multiplied by the UG value of the glass, which is the border U value on the right-hand side. From the Edit menu choose Derived Thermal Properties. Select Linear Thermal Transmittance. We have two flanking elements, the frame and the glass. The frame is distance 1 and glass is distance 2. U value of the frame towards the left-hand side. Here we read it as 1.2, but that's not right because it is a measure only for the heat transfer to the most left pixels. So we will override it from our calculations done in the previous video, which is 2.96. Now for the glass, the U value should be measured at the rightmost side. We click OK and close the window. We input the enforced U value for the frame, which is 2.96. Now we can run the calculation. Upon finishing, open the text output. Here in the Calculation Results tab, you can find the psi value. Thank you, see you in the next video.